Okay, now it's time to go to the visual weld. Alright, so we're going to open our file. I'm going to the SYSWELD 3D MMAW and the VDB file. I'm going to open. Here it is, our file. Now the first thing to do is to go to the welding trajectory. Okay, now as you see here, we are under 3D model and we are going to start select our start node. So how many nodes do we have here? 1, 2, 3, 4, 5, and here we have 1, 2, 3, 4, 5. So this one is going to be our starting node from the middle. Here we have 1, 2, 3, 4, 5 on this side, and we have 1, 2, 3, 4, 5 on the other side. Right, it's exactly in the center, and right now we're going to select our reference, which is should be on the corner of the weld. So this is our first and start node path and the reference. We're going to confirm this is a welding start and the reference start, and now we're going to rotate and do the same thing here. I believe this one is the start one. 1, 2, 3, 4, 5. Yeah, true. And I'm going to select this one as a reference. So this is welding end and reference end. So let's switch to the isometric view, and here we see the preview of our weld path and the reference path, which is great. Now I'm going to apply it and it is okay. Alright, now it's time to go to the Welding Advisor. Alright, I would like to name it 3D MMAW, and the working directory should be the same. And let's go to the solid, and it's okay, this one should be solid, and we can go to the material selection. Okay, now we select our components from here, 316L, and we're going to select left, and we can hold control and select right, and it's okay. Then add. Now we have our models that are assigned, our parts that assigned with the 316L. Now we're going to select joins with filler, 316, and the weld. Alright, now we have to add this one. Now we're allowed to go to the next part. We are going to select the general arc, which is exactly the same as the manual metal arc. Right now we're going to select the weld line. This is the weld line, and we are going to select the filler weld and the weld group. Okay, we can go next. The velocity should be 3.5. The initial time is 0 and the total time is this. We're going to set this one as 10, the width of 6, and the penetration of 5. And I'm going to explain something to you here. Imagine we are going to simulate a real welding process, and we might not have the actual energy, but in joule per millimeter, and they are going to give us the measurement in watt, and the thing we can do is to divide the energy in watt over the velocity, and we are going to have our energy. So I'm going to open the calculator, and let's say we are going to do that with a 2200 watts, and we divide that by 3.5, and we are going to have this number. So this is our units in joule per millimeter, so 628.5066, and we can add it said invalid penetration value. Let's see. Alright, the value should, when you click on the other one, is going to be okay, so it should be in decimal. Here we see the Golduck ellipsoid, which is okay to me, and I think we're good to go to the next part. We are going to select the heat environment, so this is the heat environment, and we click add. Now we're going to the cooling condition, and I would like to select 25. Oh, oops, it should be 0, and the final time should be 2500, and it's okay. Now we go to the clamping condition. Alright, I'm going to select X rigid, and I'm going to select all, and I select XYZ. Now I'm going to select X and Z, and I select this one. Now I'm going to select only Z, and I select this one. Now add. Oh, I'm sorry, I have to do that one step at a time, so we're going to go through it again. So XYZ, all, this is it. This one is only Z, and we're going to select XZ, this is it, XZ, XYZ, and Z. Alright, so in clamp I'm going to select all of them by holding Control or Shift, and I can select all of them here, and 2500, then add. This is the clamping conditions, and we can go through the next step. Alright, here I'm going to talk about the function database. Here we have a function database. If we click on this, we see we have a FCT file. We can open it with Notepad, and you see there are a bunch of different explanation here. This is the explanation from the previous video we had, which are for the Golduck double ellipsoid, but here we have other things here. We can modify, for instance, the QF and QR from here and use this function database. You can modify lots of things. Take your time and look at this file. If you want to do that for your project, you can modify this file and select it. Alright, here we still don't want to do the mechanical for this video, and say generate input file. The input file is generated, as we can see here, and we select the solve 3D MMAW, open thermometallurgical, compute, and let's do this. As you see here, it's turned blue, which means it's doing the calculations, and while it turns green, it means the results are ready. So if we click on this one, we can see the log file, and in the folder that the results are created, you can go and check that one step at a time for like large size simulations that are time consuming. But right now we can wait for it to finish. It should be ready anytime soon. Alright, this is finished. Now we can go and see the results in the visual viewer. See you in next video.